Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Coordinate Arrows by Fill the Hat, and here are the rules. We have normal Sudoku rules apply, where each row, column, and 3x3 box must contain the digits 1 through 9. We have the sum of two digits along an arrow must equal the digit in the cell at row X, column Y. Oh, that's interesting. Where X is the first digit on the arrow and Y the second, which is the arrow tip. No two arrows reference the same coordinate, and this is the coordinate arrow rule. That's why this puzzle is called coordinate arrows. I've never seen this rule set before. So the sum of the two digits along an arrow equal the digit in the cell at row X, column Y, where X is the first digit on the arrow and Y is the second. And no two arrows reference the same coordinate. So you could have something like 2 and 7, which would mean row 2, column 7 must have a 9 because it must be equal to the sum of those two digits. And that's an example of how coordinate arrows works. Interesting. Clues outside the grid equal the sum of all digits in that row or column sandwiched between the 1 and 9. So this is a sandwich Sudoku. Normal. So basically the digits between the 1 and 9 add up to 0, which should tell you a decent amount. The digits in this column, or sorry, this row, must add up to 8 between 1 and 9. The digits in this row between the 1 and 9 must add up to 14, etc., etc. So you could have something like 1, 2, 5, 7, and 9, and that would satisfy this row, right? Because the digits between the 1 and the 9 add up to 14. And that's how sandwich clues work. Sandwich Sudoku clues work. And we also have two digits separated by a white dot differ by 1. So this is white Kropke dot. If this were a 6, this would have to be 5 or 7 because those digits have to be consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so the one that sticks out to me is the arrows all pointing to the same central digit. That means this must sum to 9, up to 9, with all of these digits. So this must be 1. Right? With 1, 2, 3, 4, 5, 6, 7 other digits, only the 1 can ever add up to 9 or less. If you had 2, you can't add up with 9, 8, and 9 and 8 to add up to less than 9 or less. So this has to be a 1. None of these can be 9. This has to be a 9 then. So that means the 1 is the column, right? Because that's the second digit. The digit in the tip is the Y digit. So that means 2, 1, wherever 2, 1 is, so 2 and 1 has to be 3. So this is 3. 3, 1 would be 4. 4, 1 would be 5. 5, 1 would be 6. 6, 1 would be 7. 7, 1 would be 8. 8, 1 would be 9. So we don't know what these are. These are 1 or 2, right? This is 5. Okay, so these are the crusts of the sandwiches. So the rest of the sandwiches in the same box and the same column cannot be crust. Okay. This is row 5. This is 1, 2, 3, or 4. Row 5. Oh, The same, no two arrows reference the same coordinate, so this cannot be 5, 1. So it's either 5, 2, 3, or 4, which means 5, 2 could be 7, 5, 3 could be 8, and 5, 4 would be 9, but that's not possible. So this is 5, 2, or 5, 3. Well, if this is 5, 2, and this is 7, we already have a 7 in the box, so that can't work. This has to be 5, 3, which forces this to be 8. Okay. That means 5 and 3 cannot be any of these. What is the rest of box 4? We have 1, 2, 4, and 9. And this cannot be 9, obviously. This can't be 1. What else? 3 cannot be any of these. That doesn't tell us very much. Okay. This can never be 2, because if this were 2, that would make this 1 and 2, which is row 1, column 2 equals itself. Actually, this just can't be 2, period. Well, okay, so that would force us to be 1, 2. Okay, so that makes sense. If this is 2, that would mean 1 and 2 equals 3, but that's not possible, so this can't be 2 either. This could be 2, 1. That satisfies that. 2, 1 also satisfies that. So this could be 1. This cannot be 3, 4. It could be 5, 6, 7, 8, 9. Can't be 9 because the digits on an arrow can never add up to, cannot have 9 in them. Because if you had a 9, the problem is, okay, so let's point out which ones are pointed out to. Okay, this is a crust. None of these can be crust. These digits could be 2, 1. So what is already pointed at, right? We know all of these are pointed at. So all of these are pointed at by these arrows. So these are all pointed at. This 5, 3 points to the 8. So those are all pointed at. This could be 2, 1. Oh, wait, no, it cannot be 2, 1, because that would point at this one, and we already have a 2, 1. So this cannot be 1. This can't be 1 for the same reasoning. This could be 4, 5, 6, 7, 8. Oh. One of these has to be... No, actually, these are fine. Okay. This can't be 8. 8 in column 2 is one of these 3 digits. This is the same row. What digits can this be? 1 through 7. Can we remove anything? So if this is 1, okay, this can never be 1. Oh, it could be 1. It could be 1, 1. That's possible. These are the digits 1 through 8. So this could be 1 as long as this is 1. Can this be 2 and 1? Yes. Can it be 3 and 1? Wait, no, it cannot be 2 and 1. It cannot be 2 and 2. It could be 2 and 4. That's pretty broad, too. Oh, this can't be 1 or 9. Because this is not a sandwich. This is not a sandwich. this can never be a sandwich because the digits between in row 4 do not have 0 sum between them. And this would not have a crust anywhere next to it. So this cannot be crust, which means this is 2 or 4, which means this is definitely crust, and one of these two is a crust. So therefore, we have 2 crust already in box 6, which eliminates crust from the rest of the box. These can't be crust. Therefore, this must be 9 and is crust. One of these is crust. We don't know which. This cannot be 1. Therefore, it's 2, 6, 3, 4, and 5 as possibilities because you can't have a 7. What you cannot have is a 4 here. If this is 4, that forces this to be 1, and between the 1 and 9, you have to have 4 and 4 adding up to 8, which is not allowed. So this can't be 4. This could be 1 or 2. If this is 1, this has to be 8. If this is 1 here, this is 2, and this is 6 adding up to 8. So if this is 1, this has to be 1. If this is 2, that forces this to be 1, which makes that 4, so that's 2 and 2, which is not allowed. 2 and 2 does not add up to 4 because we have a 4 in the box. So this can't be 2. What about 4? If this is 4, 4 and 4 could add up to 8, so that could be fine. 2 and 2, 1 and 1 could add up to 2, so that would be fine. 4 and 4 add up to 8, that's fine. 3 and 1 could not add up, well, cannot point to that. So this can never be 2. If this were 2, this would have to be 1. Oh, that's not true. Never mind. Right. Seven and 1 cannot be pointed at. So the only way this is 1 is if this is 1 pointing here to 1, right? To add up to 2. Because every other digit in column 1 is pointed at except for, yeah, these. Oh, we could sort of figure out which digits can be pointed at, right? Because they must sum up to what the row and the column add up to. So this can never be pointed at. I guess we'll make that pink. I don't know. This can never be pointed. Maybe we'll make it dark. That can't be pointed at because 2 and 2 add up to 4. This can be pointed at if this is 2. 1 and 2 do not add up to here, so that can't be pointed at. 1 and 3 adds up to 4, so that's not pointable at. 2 and 3 does add up to 5, so that could be pointed at. These could be pointed at. This, okay, so none of row 9 can be pointed at, and none of column 9 can be pointed at, because that's already 9 and 1, which must be 10. 8 and 8 can't be pointed. None of these can be pointed at, I don't think. 8 and 8 can't be pointed at. It's actually, I think, all of these can be pointed at here, right? Up to here. So everything behind that cannot be pointed at, right? 7 and 3 already adds up to 10. Yeah, so anything adding up to 10 cannot be pointed at. So none of these can be pointed at here. That's actually interesting, right? So it's basically, this is the line. So we'll just draw that line here then. Not black, let's make it red. So this is the line of digits that can be pointed at. Okay, then we can remove the darks, except for these that we already showed cannot be. So we can just, oops, no, we want to remove darks. Okay, so Anything up to the upper left of that line can be pointed at. Okay, this is 4 plus 4, so it could be 8. 5 and 2 does not add up to 9, so that can't be pointed at. This can't be pointed at. This is already pointed at. 4 and 3 add up to 7, so that can't be pointed at. 6 and 2 is 8. 6 and 3 is 9. These all have to be 9, essentially, to be pointed at, so this can't be. These two can't be. Again, 5 and 4, 4 and 5. This could be a 9, so that's fine. These could be 9, so that's fine. This is a 1 or 9. We're not sure which. Oh, 9 cannot be on the arrow, so this has to be a 1. So this is something 1. Oh, this has to be 1 and 1. Because this has to be pointed at, and it has a 1 in the column, it cannot be 9 and 1 because that adds up to 10. It has to be 1 and 1. So this is 1 and 1, which forces that to be a sandwich. That means this is already pointed at, and it has to be a non-sandwich. So this is sandwich and can never be pointed at. So this is 1. So this is 2. It cannot have 8 here. Okay. So this 1, 1 already points there. This cannot be 1 then. That forces this to be 1, which makes this an 8, 1. This can no longer be 1 then. 3, 4, 5, 6, 7. We have 9 as one of these. We're not sure which. This sandwich clue makes this an 8. Okay. 2 and 2 can't add up. 3 and 3 could add up to 6. That's fine. 2 and 3 add up to 5. That's fine. 2 and 3 add up to 5. Okay. So these are all done. This arrow's done, obviously. This is 1 with 4, 5, 6, or 7. Those all work. 1 and 9. So 9 is either here or here. So this cannot be sandwich. And these cannot be sandwich. Two. 7 and 2 does not work because that is not allowed to point there. So this can't be 7. 6 and 2 or 6 and 4 does not work. So this can't be 6 because 6 and 2 would have to be 8, but that cannot be an 8. 5 and 3 is already pointed to, so that doesn't work. 5, 2, and 4 both don't work. So 5 doesn't work either. 4 and 4 works. 4 and 2 does not. 3 and 2 works, and 3 and 4 works also. So this is 3 or 4. Okay, 3 and 1 does not work. 4 and 1 does not work. 1 can never be basically on the point anymore of these tips. So the points of these tips have to be 2 through whatever. 2 through 8, but this can't be 8 because of the 8 in the row. This can't be 1, 2 through 8. So these are not crusts. Guaranteed. 1, where is the 1? In box 9. Can't be here because of the 1s in the columns. Can't be here, and it can't be a tip again because we have all the tips that we can point to, right? All of them are already pointed to. So this must be a 1 here. and is the crust. None of these can be crust then. We're waiting for a 9. 9 can never be on an arrow, so this can't be crust. Therefore, this is crust here. So this is 9, which means the rest of the column cannot have crust. This must add up to 8, so this is either 2, 6, or 3, 5 here. To add up to 8. This can't be 6, so this can't be 2. 1 and 2 does not add up to 3. 1 and 3 does not add up to 4. So none of those are correct. So we have another 1, 4, 5, 6, 7. This can't be 8. Can't be 7 either, because this can be at most 3 and 6. This cannot be 8. This could be up to 2 through 7. 1 must add up to 9, so it cannot be here. So these are not crust. None of these are crusts, actually. Actually, oh, this is a crust. Where is the crust? In column 2. Can't be here, it must be here, right? We're looking for 1. 1 can't be here because of the 1 in the box. Can't be here, and can't be here. So this must be, again, this is not crust. This has to be crust, which makes this not crust. This is a 1, and this has to be 8 because that's the only digit remaining. That's the only place where 8 can be now in column 2. So since this is 8, that's not the sum of 3 and 2. So this is not available to be pointed at. We have a 1, one of these places. 9 cannot have 4 digits in between to add up to 9. So this can't be 9 here. This is 9 here and is a crust. This is not crust. That means these add up to 9. So this is 2, 3 with and 4, 5 here. 2, 7, 3, 6, or 4, 5 pair. Okay, so this is 9, which means 9 must be one of the digits here. 1 and 9 cannot be here, so that cannot be crust. 1 and 9 cannot be here, so that can't be crust. So one of these two is crust. Yeah. One of these is a 9. Okay, what else? 1, 4, 5, 6, 7. Okay, so the rest of column 3, or actually box 1, is 5 through 9 without an 8. This could be 3 and 2, so that could add up to 5. This could add up to 6. Okay, this can no longer be 8, which would be 4 and 4, so this can't be crust. Or sorry, this can't be pointed at. So these have to add up to 9. This can no longer add up to 9, so that can't be. So this cannot be... Oh, we didn't have 1 and 8 actually in any of these, so... Okay, this, well, it could be 3, 2, and 3, 4. Okay, 3 and 2 does not work anymore, right? Because we know there's an 8 there. So 3 added with 2 adds up to 5, and 8 does not do that. So this cannot be 3 and 2. If this is 4, that has to be 4, guaranteed. And you can't have 4. Okay, so 4 and 4 doesn't work anymore because this can't be 8. So this must be specifically 3 and 4. That makes this 2. None of these could be 4 here. This has to be a 2, 3, 5, 6 triplet or quadruplet left in row 6. 3 and 4 add up to 7. So row 3, column 4 is pointed at and is a 7. That means none of these can be 7, so these are not pointed at. What else do we have? 3 cannot point to 1, 2. This can't be 7 anymore. It cannot point to 1 or 2, so 2 is out. Cannot point to 4 anymore, so 4 is out. Could point to 5, could point to 6. So these could be 9. These have to be 8. These have to be 7, 6, 5. So we have 2 and 5 does not work anymore. So this is 6 or 7. This can't be 3 and 6 adding up together. This can't be 4, so this can't be 5. This is 1, 5, which makes that 6, or 1, 7, which makes that 8. It's possible. 3 and 3 could add up to 6. 3 and 5 could add up to 8. Oh, cannot add up to 8. So this is not possible here. So this cannot be 3 and 5. 3 and 6 though could still add up to 9. Okay, remaining digits in column 3. This 2 eliminates 2 here, so this must be 4 and 5 adding up to 9. So 1 and 5 must add up to 6. So 1 and 5 must be 6. So this is pointed at. And the 6 cannot be here anymore, so this is ruled out. 2 and 4 is ruled out. This cannot be 4 or 5. 7 with anything is ruled out because that would have to add up to 9. That's not a 9. This is 2, 6, or 7 possibly in column 2. And we have no 5 or 9. This is 6 or 7 here in column 3. So 7 cannot be here. 6 doesn't work either. 1 is already pointed to, 2 and 3 are out. 2 and 3 could be, but 2 and 2 can't be pointed to. 3 and 2 can't be pointed to, so this can never be 2. Any of the 3s could be pointed to, though, so those are still fine. 6, again, cannot be pointing to any other digit. 1 is already pointed at. 2 and 3 cannot be the correct sum. 5, 1, 3 are already pointed at, and 2 and 4 cannot be pointed at, so it can't be 5. This becomes a 2, 3, 2, 3 pair. Can you point at 5 anywhere? No. 2 and 5 doesn't work. So this is 2 or 3. One of these two digits must be 2 or 3 to add up to 8. Therefore, that eliminates 2 and 3 in the rest of the box. This can't be 2 or 3. We have a 2, 3, 5, 6. So one of these two is a 6. Right? Because either this is 2, 6 or this is 2, 6. Because this would be 3, 5. So this can never be 6. The rest of box 6 has to be 4, 7, 8, and 9. These cannot be 8 and 9, so this is 4, 7, which forces these to be 8 and 9. That leaves the rest of row 4 to be 4, 6, and 7. This can't be 7, this can't be 6. That leaves the rest of box 5 to be 2, 3, and 5. Okay. Okay. 1 cannot point to 5 anymore because we already have a 1, 5. 1 could point to 4. That could be 5. 1 could cannot point to 6 anymore. So this is not 6. This is 4 or 7. In column 9, we have a 2, 3, and a 4, 7 pairs. That eliminates 2, 3, 4, 7 in the rest of the column. So this must be 5, 6, 8, and 9. Well, this can't be 6. This can't be 8. Okay, one of these is a 9. We're not sure which. So this can never be 9 here, but it still could be 8. Hmm. One is next to one of the 9s. Okay. So where's the 1 in row 7? It cannot be here because this digit cannot add up to 14. So this is not crust. This is crust here, which eliminates crust in the rest of the column. Therefore, one of these is crust, and then one of these is crust. Well, where's the last one? This has to be a 1. Where's the last one, actually? We should have 8 ones now. We do. Where's the last one? In box. Well, where's the last one? It has to be here. So this is 1 and is red. 9 is one of these two. 9 could be here. That could be crust. This could be crust. Okay, so I think so we have already this set for row 4. This has to add up to 14. Okay, that's interesting. Without a 3, what 3 digits add up to 14? Well, I think it has to be 2, 5, and 7. We don't have an 8 either possible. So 6, 7, 1 doesn't work because 1 can't be in between 1 and 9. 2, 5, 7 does work. I think that's it, right? 2, 5, 7. So we need a 5 here in between because 5 cannot be here and 5 cannot be here. So 5 is in between. That means the other 2 digits must add up to 9, right? 14 minus 5 is 9. We can't have 1, 8. We can't have 3, 6 because we have a 3 already. 5 is already taking account, so this has to be 2, 5, 7. So that 2, 5, 7 eliminates 2, 5, and 7 in the rest of the row. So this can't be 7. This is 4. This can't be 2 or 7, so this is 6, which makes this 7, which makes that 2. This 6 eliminates 6 here, so that's 7. None of these could be 7 then. That means 1, 4 must point to a digit, so it must be 5. So this is 5 and pointed at. 2, 7 must point at a digit, so it must be 9. And that's red, and it's pointed at, so it's green. This can't be 9. This is 8, which forces this to be 9. 9 cannot be any of these. 8 cannot be here anymore, so this can't be pointed at. 9 cannot be here. Where is the 9? 9 has to be here then, in column 6. Therefore, none of these are 9. Therefore, this is a 9 here and is a crust. Cannot be pointed at. 8 could still be pointed at here. 5 and 6 could still be pointed at here. So could the 9, actually. 3 and 6 works too. 3 and 3 still work. One of these is 2. The other one is 3 here. Okay. 2 and 7 are already pointed at. So this can never be 7 anymore. None of the column 7s can be pointed at anymore. So this is 3 or 6. Actually, what are the remaining digits in box 3? We have 2, 3, 4, and 7. This can't be 2 or 7. Therefore, this must be a 2, 7 pair here. Therefore, this is 3, 4. This 5 eliminates 5 here, so this is 8. That means this can't be 8. This 2, 7 pair eliminates 2 and 6 as the digits adding up to 8. So this is a 3, 5 pair, which eliminates 3 and 5 in the rest of the box. This must be 2. This must be 6. This can no longer be 2. We have a 3, 5 pair also in column 8, which eliminates 3 and 5 in the rest of the column. This can't be 3. This is 4. This can't be 4. It's 3. This 3, 5 pair also eliminates 3 here, so this is 6. 2 eliminates 2 here, so it's 3. That's 3 in the corner. We celebrate because we know we're getting close to solving this. The last digit remaining in column 8 is an 8. We have 2, 5, and 7 remaining in box 9, which eliminates 2, 5, and 7 in the rest of the column. So this can't be 7. This is 4, which makes this a 7. We already knew that, actually. So we have 3 and 6 being pointed at, which is a 9. So that's pointed at now. This 7 eliminates 7 here, so this is 2, this is 7. So, okay, we've got 2, 7 pointed, that's correct. 5, 3, that's fine. 3, 4, that's fine. We already have 3, 6 here, so this has to be 3 and 3. So that points to here, and these are not crusts. So these are all the crusts are done. So we can just actually just remove all those. So this must be 6, which forces this to be 5. This 6 eliminates 6 here, so it's 5 and 6. This must be a 3. We have... This can't be 5 anymore. This can't be 2 or 7, so this must be 5, which means this can't be 5, and this can't be 5. These digits are consecutive. We only have an 8 left here, so it must be 7 and 8 consecutive. That forces this not to be 7, so this is 2, this is 7. These cannot be 7. We have a 2, 3, 5 triplet in column 6. I don't know if that helps us much. It does, because 3 eliminates 3 here, so that's 2. Okay, that's fine. That leaves this as a 4 or 6 in column 4, but it can't be 6, so this must be 4, which makes this 6. That means 6 cannot be here. This must be, for column 6, we've already pointed to 9, so it has to be 2 and 6, which makes this 8. So that's pointed at. This must be then 2, cannot be 5, so it must be 2 and 3 pointed at. So this is 3, this is 5. This 3 eliminates 3 here, so it's 5, which makes this 2, which makes that 5. This can't be 2 or 5, so it's 3. 8 eliminates 8 here, so it's 7 and 8. That 7 eliminates 7 here, so it's 4 and 7, which leaves this as a 4 and that as a 9. Ooh. Do we have a contradiction? We might. Okay. Let's remove the coloring. We might have a contradiction. Oh, this can't be 9. I don't know why I had 9. This is 4, and this is a 6. Okay, that's the solve. Pretty interesting, actually. Let's just go through everything just to make sure we have everything covered. Okay. 1 and 9 are next to each other, therefore the digits in between add up to 0. 1 and 9 are added up together, or next to each other, therefore the digits in between add up to 0. We have an 8 between 1 and 9, that adds up to 8. We have 2, 5, and 7 between 1 and 9, which adds up to 14. We have 3 and 5 between 1 and 9, which add up to 8. And we have 4 and 5 between the 1 and 9, which adds up to 9. Okay, 2, 7 points to 9. So that's pointed at, and this is done. 2, 6 points to 8. So this is pointed at, and this is done. 1, 1 points to 2, and that's pointed at, and so this is done. 5, 3 points to 5, row 5, 3, so this is pointed at, and this is done. 6, 1 points to 7, so this pointed at, this is done. 7, 1 points to 8. We have 4, 1, 3, 1, 5, 1, 8, 1, and 2, 1. So those are all done, and they point to all of these. 3, 4 points to 7. So 3 and 4, that's pointed at, and this is done. 3 and 3 points to 6. That's pointed at, and this is done. 2, 3 points to 5. So that's done. This is pointed at. 1, 4 points to 5. That's pointed at, and this is done. 1, 5 points to 6. So this is pointed at, and this is done. And 3, 6 points to 9, which it does point there, and that's pointed at. So that works. So that shows you exactly where every arrow is pointing to and where it's coordinated at. Very cool, actually. Yeah, it's the first time I've ever done anything related to this. I think this is a relatively new rule set. So, and basically all the 9s are possibly here. Yeah, so basically it was forming the step ladder, right? Where basically all the coordinated arrows must point to essentially their sum in the diagonal they're on. So these diagonal must add up to 2, this diagonal must add up to 3, this diagonal must add up to 4, this diagonal adds up to 5, this diagonal adds up to 6, this diagonal must add up to 7. So actually you can sort of tell what limits you have, actually. You could have actually, yeah, figured it out by counting how many arrows you had and figuring out what limitations you had here. I guess this one was maybe the only one. These two, you could have had an extra one here. That might have been a little difficult. I don't know. That would be interesting. Just depending on how many arrows you had. You didn't have all the 9s. You could have had 9 here too. You could have had 9 here also. So there were, okay, so counting the arrows would not have done anything. We did have the maximum 2s, we had the maximum 3s, we had the maximum 4s, we had the maximum 5s, we had the maximum 6s, we had the maximum 7s. We did not have a maximum 8, we could have had one more. We did not have the maximum 9s, we could have had 2 more. That's interesting. Huh. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.